Hi everyone, this is Daniel Hall, and this is just a really quick video about how to classify matter as one of the first units on the GCSE course as well as other courses. The objectives for today's session is to go through the following. So it is to understand the difference between atoms, molecules and lattices, to understand the difference between elements and compounds, and also to classify the substances. I'll have a particular emphasis on the definitions of the first few things such as atoms, molecules and lattices, so forth, because that's what I think students struggle on a lot. And then we'll do some classifying, which again I find students can find quite tricky as they're working through more complicated things. So in terms of the first definitions, I want to go through atom and then molecule and then lattice. And lattice is something which I think a lot of teachers don't touch on as much as they probably could do. An atom basically is just a single particle of matter. So we're thinking about things which are basically floating on their own. They're pretty much always gases. So we think about things like helium, neon, argon, things like that. There's not many of them which act as atomic substances, but they are out there. You've then got molecules, which form a lot of the things out in the natural world. So these are substances which are made of more than one atom and they're chemically bonded together. In your definition, you have to emphasize they're chemically bonded, because then you might you have to make the distinction between that and also a mixture. So we think about things like this. So this is an example of a molecule. You see they're chemically bonded together, and this is another example. We've got different types of atoms in this one, which we'll come to later on, but those are both examples of molecules. One thing to mention about them as well is that they're quite small, they're quite simple, and they're quite discrete, and that's very different to lattices. Now, lattices are ordered arrangements of particles. Now, these arrangements, what you can see there is a picture of an example of a lattice. I've got it in a 2D version. You can sometimes get them in a 3D version. And although over here you can see I've just sort of created a 6x4 picture, lattices kind of go on for billions and billions of atoms, okay? And what you always see in these kind of pictures is just a cross section of it. It's almost like a slice of cake from a very large cake. That's all it is. So that's a lattice, that's a molecule, that's an atom. And pretty much every single piece of matter that we know can be classified in those three different ways. But then we can classify matter in two other ways in terms of whether they're elements or compounds. Now, an element is one type of atom. So if it contains one type of atom, it's an element. So an example would be, of course, anything that's atomic, because if it's atomic by nature, it's going to be on its own. Also, if it's a molecule, it could also be an element, as long as the atoms that are chemically bonded are the same as well. So that's an example. And then lattices, as long as the atoms are all the same in a lattice, that can be considered to be an element. Compounds are a bit different. A compound is when you have more than one type of atom chemically bonded together. I've emphasized type in my definition because it's really important that when you write that definition, you write it's more than one type of atom. If you just write more than one atom, yeah, it could be confused with a molecule, and then you won't get the credit for it. So examples of compounds are the following. So here's like a simple compound is also a molecule. We'll talk more about the classification in a minute. There's another example of a molecule over here. And then here at the bottom, that's an example of a lattice, which is also a compound. Now, often what you'll get as a picture of a lattice compound is something like this, where basically it alternates the places of different atoms. Now, I've used red and blue to designate the different atoms inside it to show it's a compound. You could also use letters inside it. So, for example, if it was sodium chloride, it'd be Na in one, Cl in the other, and so forth, alternating like so. Okay, so those are the definitions that you definitely have to know. The bigger challenge is how to apply this. If I've given you a substance, and then you have to say whether it's an atom, whether it's a molecule, whatever, that can be slightly trickier. And one way of doing it is by using something like a table in order to help classify the matter, because basically you can classify matter in two different ways. So on the left-hand side, you can see I've got element and compound. That's one or two ways in which to classify matter, and at the top I've got atom, molecule and lattice, and we'll just use this framework in order to classify the matter that we've got on the top left. So here we've got helium, which is probably the most basic noble gas that we know. So the first thing we need to think about is whether it's an element or a compound. Now it's on its own, there's only one type of atom, so it's definitely an element. And then when I look at whether it's an atom, a molecule, and a lattice, I can also see that it's on its own, it's definitely atomic. Therefore, I say that this is an atomic element. Okay, so that's how you classify it. If I go to the next one, this is water, or H2O. Now, H2O is made of one oxygen, which is the red atom here, and two hydrogen, which are the white ones. So what I now need to do is I need to work out, first of all, whether it's an element or a compound. Now, I look inside it, I can see the white ones and the red ones, they represent two different elements inside this substance. So it has to be a compound because they're chemically bonded together. So I definitely know it's a compound. I'm just going to put a tick here for now, and I'll come back to the other classification in a minute. I then look at the other three, and I have to work out whether it's atomic, a molecule, or a lattice. Now, it's definitely not a lattice because it's not this kind of massive 3D arrangement. It's also not atomic because it's not in its own. So it has to be a molecule. Therefore, I'm just going to give that a tick. So overall, it fits into this box. So I say that water is a molecular compound. Simple as that. Let's try another one. If I look at this one, this is ozone, which is the formula O3, which is pretty bad for health, but pretty useful in terms of keeping UV out of the atmosphere. Again, let's have a look and see what this is. So if I have to classify it as an element or a compound, I look at all the atoms here, they're all the same. So it can't be a compound because I've only got one type of atom inside it, so it has to be an element. I then look at the top here and I have to work out whether it's atomic, a molecule, or a lattice. Now, it's definitely not atomic because it's not on its own. It's definitely not a lattice because it doesn't have this massive 3D arrangement that you often see in other substances. So it has to be a molecular substance, so it's a molecule. So if I kind of cross-reference the two, it fits here. Therefore, I know it's a molecular element. And then just try one more. This is the lattice for sodium chloride, or NaCl. You can see it's a huge 3D structure. And as soon as you see that, you know it's going to be one of three different things. So if I work out whether it's atomic, molecule, or lattice, it's definitely not atomic because it's not on its own. It's definitely not a molecule because it's not this kind of discrete, just two or three things together. So it has to be a lattice, so it has to fit in right there. And then if I look at whether it's an element or a compound, well, there's definitely more than one type of atom chemically bonded together, so it can't be an element, so I'm going to leave that out. It has to be a compound, so it has to be this. So if I cross-reference the two, it fits into this box, so it has to be a compound lattice. And that's how you do it. So I hope this has been useful, and good luck with classifying your elements, compounds, and mixtures.